Imagine for a moment that you discovered an invisible, mysterious force is literally tearing the fabric of the universe apart at this very instant, pushing galaxies away from each other at an ever-increasing speed. Now imagine that this force accounts for 73% of everything that exists in the cosmos, but we can't see it, touch it, or detect it directly. This isn't science fiction. Cosmic explorers, this is the most unsettling reality modern cosmology has ever uncovered. Welcome to another episode of Cosmic Frontiers, where we unravel the deepest mysteries of the universe. I'm your guide on this cosmic journey, and today we're diving into the most enigmatic and terrifying phenomenon in the cosmos: dark energy. Get ready to discover how a force we can't detect is determining the fate of all galaxies, stars, planets, and, yes, all of us. We'll explore the discovery that revolutionized our understanding of reality and confronted us with a universe far stranger than we ever imagined. And cosmic explorers, we're on an incredible journey towards our first 1,000 subscribers. Each one of you is fundamental to this cosmic expedition. Let's begin our exploration by going back to the late 1990s, when two groups of scientists were doing something seemingly simple: measuring the speed at which the universe expands. It was like trying to measure the growth of a gigantic soap bubble. But instead of using a ruler, they used the brightest explosions in the cosmos: supernova. Imagine cosmic lighthouses so luminous they can be seen billions of light years away. Type Ia supernova are like standardized lamps of the universe. They always explode with approximately the same brightness. This means that by comparing the brightness we see from Earth with the brightness we know they should have, we can calculate exactly how far away they are. It's like looking at a 100-watt light bulb. If it looks dim, you know it's far away. If it looks bright, it's close. The two groups, one led by Saul Perlmutter and another by Brian Schmidt and Adam Rees, expected to confirm something that seemed obvious: the universe was expanding. Yes, but this expansion should have been slowing down. After all, the gravity of all the matter in the cosmos should have been breaking this expansion, like a gigantic cosmic break. It was like expecting a ball thrown upwards to eventually slow down due to Earth's gravity. But when the data came in, reality smacked them in the face with a shocking discovery. Distant supernovae were dimmer than they should have been. This meant they were farther away than expected. And if they were farther away, that could only mean one terrifying thing: the universe wasn't just expanding, it was accelerating its expansion. Pause for a moment and let that sink in. The universe, which should have been decelerating due to gravity, was actually accelerating. It was like discovering that a ball thrown upwards, instead of slowing down, started accelerating faster and faster towards space. Scientists were so shocked they spent years checking and rechecking their data, desperately looking for some error. But there was no error. In 2011, Perlmutter, Schmidt, and Rees received the Nobel Prize in Physics for this discovery that changed everything. They discovered that there is something in the universe that is overcoming gravity on a cosmic scale, something scientists dubbed dark energy. But what in the Lord's name is this dark energy? Well, the honest and somewhat humbling truth is, we have no idea. We know it exists because we see its effects, but it's like trying to understand a ghost just by observing the doors it slams. Dark energy is called dark not because it absorbs light, but because it's completely invisible and undetectable by all our instruments. It's as if 73% of the universe is made of something that exists in a parallel dimension to our observable reality. To give you an idea of the magnitude of this mystery, imagine discovering that 73% of your own body is made of something you can't see, feel, or detect, but which is constantly influencing everything you do. Dark energy permeates all of space. Every cubic centimeter of the universe contains a small amount of this mysterious substance. And here's the crucial point: unlike normal matter, which dilutes as the universe expands, the density of dark energy remains constant. This means that as the universe grows, there is more and more dark energy in absolute terms. It's like having a swimming pool where, no matter how much water you add, the chlorine concentration always remains the same. Magically, more chlorine appears out of nowhere. In the case of dark energy, as space expands, more dark energy simply emerges to maintain constant density. This is deeply unsettling because it violates our basic intuition about energy conservation. According to our current understanding, dark energy has a unique and terrifying property. It exerts negative pressure, a kind of anti-gravity that pushes space to expand faster and faster. Imagine that every point in space is being pushed by an invisible force that says, move away from all other points and do it faster and faster. It's as if the very fabric of space-time is being inflated by an invisible cosmic bomb that never stops working. In the first billions of years of the universe, when matter was more concentrated, gravity dominated. But as the universe expanded and matter became more diluted, dark energy began to win the cosmic battle. And this leads us to one of the most chilling predictions of modern cosmology, the Big Rip. If dark energy continues to accelerate the expansion of the universe, an apocalyptic scenario awaits us. First, distant galaxies will disappear from view, being dragged beyond the observable horizon. Then, our own galaxy will begin to unravel, with stars being torn away and flung into the void. Next, the solar system itself will break apart, with planets being ripped from their orbits. Finally, in a cosmic fraction of a second, individual atoms will be torn apart as space itself expands faster than the speed of light. It is literally the end of everything, not just the heat death of the universe, but the destruction of the very structure of reality. But calm down, cosmic explorers, we are still safe for now. The Big Rip, if it happens, is at least 22 billion years in the future. That's more time than the current age of the universe. But the mere possibility shows us how our existence is at the mercy of forces we cannot even fully comprehend. It's like discovering you live in a house built on a geological fault you didn't even know existed. Now, let's talk about the theories that try to explain this mysterious force. The first possibility is that Einstein was right all along, in a way he himself never imagined. When Einstein developed the theory of general relativity, he realized that his equations allowed for an expanding universe. But at the time, everyone believed the universe was static and eternal. To correct this, Einstein added a mathematical term called the cosmological constant, essentially a repulsive force that would counterbalance gravity and keep the universe still. When Edwin Hubble discovered that the universe was indeed expanding, Einstein called his cosmological constant the biggest blunder of his life and removed it from his equations. But here's the cosmic irony. The cosmological constant may have been exactly what Einstein unknowingly predicted. If dark energy is truly the cosmological constant, it means there is a fundamental property of spacetime that causes it to have an intrinsic energy, that causes accelerated expansion. It's like discovering that empty space isn't really empty, but is filled with an invisible energy that has been there since the Big Bang. In this case, dark energy would be a fundamental property of the universe's geometry, as basic as the 3 dimensions of space or the dimension of time. The second possibility is even more exotic: quintessence. This theory proposes that dark energy is not a constant, but rather a dynamic field that varies over time and space. Imagine an invisible cosmic ocean with waves and currents that influence the expansion of the universe in subtle and variable ways. Quintessence suggests that dark energy may be changing, evolving, and perhaps even decreasing or increasing its influence over billions of years. If this is the case, the fate of the universe is not sealed. It could change depending on how this mysterious field evolves. There's even the possibility that our fundamental understanding of gravity is wrong. Some theories propose that the observed acceleration is not caused by dark energy, but rather by modifications to how gravity works on extremely large scales. It's like discovering that the rules of physics we know work perfectly in our backyard, but behave completely differently when applied to intergalactic distances. Theories like modified gravity suggest that Einstein may have been right locally, but that we need new physical laws to understand the cosmos in its entirety. But while we debate theories, one reality remains unshaken. At this very moment, as you watch this video, dark energy is silently at work. Every second that passes, the universe gets a little bigger, a little emptier, a little more dominated by this mysterious force. The most distant galaxies are moving away from us at ever-increasing speeds. The future of the cosmos is being written by a force we cannot see, touch, or fully comprehend. This puts us in a deeply humble position before the universe. Throughout human history, we have observed the stars and tried to understand our place in the cosmos. We discovered that we are not the center of the solar system, that our sun is just an ordinary star among billions, that our galaxy is just one among trillions. Now we discover that even the matter and energy we can observe represent only 27% of everything that exists. The rest is a total mystery: 273% dark energy and about 23% dark matter. Another mysterious substance that we also cannot detect directly. Perhaps the discovery of dark energy is one of the most important lessons about the nature of science and human discovery. It reminds us that the universe is fundamentally stranger, more mysterious, and more wonderful than our wildest imagination. It teaches us that we must remain humble before the cosmos and open to possibilities that challenge our most basic intuitions. And it shows us that, no matter how much we learn, there are always deeper mysteries waiting to be discovered. Dark energy also connects us in a unique way with the cosmos. Every atom in our body, every cell that constitutes us, exists in a universe dominated by this mysterious force. Our very existence is possible only because dark energy took billions of years to completely dominate the universe, giving time for stars to form, create heavy elements, die, and allow planets and life to emerge. We are literally children of an accelerating universe, products of a delicate cosmic balance between forces we barely understand. And here is perhaps the deepest reflection. The discovery of dark energy reminds us that living is an act of cosmic courage. We exist in a universe where 73% of reality is a total mystery, where incomprehensible forces determine the fate of everything we know and love. Even so, we continue to explore, to question, to marvel at the beauty and complexity of the cosmos. This makes our human journey even more precious and meaningful. Dark energy teaches us that the universe holds secrets that may take generations to decipher. Perhaps you who are watching this video are part of the generation that will finally unravel this mystery. Perhaps one of you will become the scientist who discovers the true nature of this cosmic force. The future of cosmology is literally in the hands of the next generation of cosmic explorers. So, when you look at the night sky tonight, remember, you are observing an accelerating universe, dominated by a force that remains one of science's greatest mysteries. Every star you see is slowly being pulled further away by an energy we cannot detect. It is simultaneously humbling and inspiring. Humbling because it shows us how much we still do not know, and inspiring because it reminds us that there are always new horizons to explore. Cosmic explorers, this is the beauty of our scientific journey. Every answer we find reveals 10 new questions. Dark energy is one of those discoveries that has fundamentally expanded our ignorance. Now we know there is much more we do not know than we ever imagined, and that makes our cosmic adventure even more exciting. I want to hear from you. What aspect of dark energy did you find most unsettling or fascinating? The idea that 73% of the universe is a total mystery, the Big Rip scenario, or perhaps the irony of Einstein having predicted dark energy without knowing it? Leave your thoughts in the comments. I love reading each of your perspectives on these cosmic mysteries. And cosmic explorers, what mystery of the universe do you want me to talk about in the next video? Dark matter, supermassive black holes, the possibility of multiverses? Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe and its mysterious forces, join our crew by clicking subscribe. Like this video if it expanded your cosmic horizons, and share it with someone else who also loves the mysteries of the universe. In the next episode, we'll dive into another cosmic enigma that challenges our understanding of reality. Until then, keep looking at the stars and remember, you are part of an accelerating universe, dominated by mysteries we are only just beginning to comprehend. The cosmos calls us to exploration, and together, we will continue to break through these cosmic frontiers.